Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. Anyways, the agenda behind the today's session, the session which we used to have on daily basis from 3 to 4 p.m. must be known to all of us. Me, Sonal Kumar Agarwal, and I am taking the concept through question for the control system, and it had been valid for the electrical, electronics as well as instrumentation all. So you can see you had to have a copy as well as pen in front of you, and whatever the important concepts we are learning through the question you should write on your copy. And end of the day, I can say almost 80 to 90% important concepts within the control system we are going to cover with the help of question itself. Okay, the schedule must be known to all of us. So precisely at 1 p.m. we used to have the classes for the electrical machine, and it used to be 5 days in a week from Monday to Friday. Bhanu sir used to take these classes, and this has been for the electrical as well as instrumentation both, because in GATE 2021 it has got added in instrumentation syllabus also. And similarly the power electronics, we used to have 2 days in a week on Saturday and Sunday. Again, the subject expert who takes this particular subject is being the Bhanu sir, and it has been exclusively for the electrical alone. Third subject which goes on in daily basis, and that has been the control system, which has been taken by me. 3 p.m. we used to have these classes, and that used to be in daily basis for electrical, electronics and instrumentation. Similarly, in the same sequence, the power system analysis do come, and precisely it starts at 6 p.m. The class would be taken by the Vishnu sir, and keep in mind it's only for the electrical alone. EMFT, the Karthik sir used to take the classes in daily basis. Here also it's been daily basis at 6 p.m. and starting 7 to 8 days it would be common for the electrical, electronics as well as instrumentation, but thereafter it would be dedicated towards electronics alone. And similarly at 9 p.m. the network analysis used to be taken place on our GATE Academy Global. The great Diptansh sir used to take these classes, and it has been for the electrical, electronics and instrumentation. If you want, you can write somewhere this complete timetable just for better use the complete time frame which we have been allocated. So how many number of subjects is been running for the electrical? It's gonna be 1, 2, 3, 4, 5 and 6. The 6 parallel subjects are running for the electrical, same like college obviously, but the quality would be the quality of GATE Academy. And similarly for the instrumentation, how many subjects is been running in parallel? Obviously 1, and here it goes 2, here it goes 3, here it goes 4. The 4 number of subjects are running for the instrumentation in the same sequence. For the electronics, 1, 2 and 3 subjects are running. So I can say more or less the electrical, electronics and instrumentation people are going to learn all of the important concept through the question itself, and around 5 to 6 number of subjects are running in parallel. So you should write somewhere this complete coursework. Bhanu sir, yes, 7 days, 5 days in a week, 2 days in a week, 7 days in a week in daily basis, 7 days in a week daily basis, similarly 7 days in a week daily basis, and again it's been a daily basis. Yeah. In the same sequence, let me move forward and let me briefly discuss about the agenda behind today's video. What are the different topics which we are going to cover with the CTQ? The 2 important topics which we are going to cover with the help of concept through the question, and the first is being steady state response of pure sine input. Sine wave input signal, you can say. What does it mean of it? That means if you have a system, the system is being referred by its transfer function, and if a certain pure sinusoidal signal. What does it mean by the pure sinusoidal signal? That means neither it might be damped in nature, neither it might be increasing in nature, or I can say it's been a pure sinusoidal signal with constant magnitude as well as frequency. If a certain system gets excited with those sort of input, how we get its output response in steady state. The question do come repeatedly, and I can say in each 3 year, one question do get framed from this particular segment. Once we are done with that, straight away we would reach into the next category of the problem, and there we are going to take around 2 to 3 number of problems based on the concept of initial as well as final value theorem. Anyways, we will try to trap with the help of few number of questions, and you can say they had been very important topic. So if you have been from electrical, electronics, instrumentation, so I can say each year in either of these stream at least one question do come from either of this particular topic. So it had been a very important topic. Yes. In the same sequence, let me move forward. The first question do come in front of you, and this has been the sixth question in series. Obviously, I have bifurcated the complete control system in 14 different module of 14 different chapter. Within the first chapter, already the 5 questions has been taken in last video, and now it's time to take around 4 to 5 more number of questions based on the concept of basics of the control system. So I would request to each one of you read this problem carefully and try to get its best most answer. What the problem states: a first order system with a transfer function 1 divided by 1 plus x is excited by a signal 10 sine t. Is steady state output would be, the 4 different options were attached along with this problem. Option A says the 10 sine 2t minus of pi by 4. B says 10 times of sine t minus of pi by 4. C says 10 divided by root 2 sine within the bracket t minus of pi by 4. D says 10 divided by root 2 sine within the bracket t plus of pi by 4. Tell me what would be the best most answer. What would be the best most answer? So the answer has started coming. According to Karunakar, the answer had been C. Anyone else apart from this? Anyways, I am going to give around 90 seconds to solve this problem out. Probably this was the question for the 2 marks. So obviously I can give the 90 seconds to solve this problem. Whatever the answer you guys are getting, Karunakar, I would request only try to give the answer once, because the accuracy also a very big part, at least while cracking gate examination. Tell me what would be the best most answer over here. So the 2 more answers have come so far. It's been Amit Kumar. Answer had been C. According to the Mayur, the answer had been C. So let me solve this problem out. The solution do start from here. See what had been happening over here. We had a system whose transfer function is clearly been given along with this problem. Let's take, it's been my system. The transfer function is being 1 upon 1 plus of s. The input or the excitation to this system is being a pure sinusoidal signal. It's been 10 times of sine of t. 10 times of sine of t. So we have been looking for its output. Keep in mind, the output would have the 2 part. It would have its transient part, which would be keep decaying, which would have the factor of e to the power of minus t, and the another would be a steady state response, which would be keep oscillating. And here it has been clearly categorically said we had to calculate its steady state output. So we don't have to focus over its transient part. We had to only and only focus over its steady state part. This has been the agenda of this question. This has been the agenda of this question. Whenever you have this sort of problem, what would be your understanding? Convert the given transfer function into the phasor form, or in form of complex variable. See what is happening over here. See, 1 would remain 1 as it is. 1 would remain 1 as it is, and obviously the s can be replaced with j omega. My dear friend, this methodology is true only and only if you have been dealing with a pure sinusoidal signal. What does that mean by the pure sinusoidal signal? That I am going to tell now. So here it becomes 1 divided by 1 plus of j omega. And now one more important thing, the input signal which has been applied to excite this signal had been a monotonic signal. What does that mean by the monotonic signal? It has got a only and only one frequency component. Instead the omega, the one has been over here. Yes, no? In standard it used to be a into of sine of omega t, the value of omega which has been exciting this signal is being omega. So the value of omega which is going to fed over here, at least for this input, is being omega is equals to 1. Omega is equals to 1. And once we do so, what happens? It would simply be 1 divided by of 1 plus of j. Whenever you get its complex form, what I would request, try to convert this particular form into the phasor form. How do we calculate the phasor form? We would calculate its magnitude. Let's take the magnitude is been r, and similarly the phase shift which would be provided, and that's been theta. May you know how will you calculate the value of r? Let me calculate over here. So the r would be equals to of magnitude at numerator, 1 had been there, so simply it's going to be root over of real part square plus of imaginary part square. It's been root over of 1 square itself, and similarly towards denominator side it becomes 1 square plus of 1 square. Put together it's been 1 upon root 2. So the value of r has been clearly known to me, and which has been 1 upon root 2. Till this point, each and everything must be clear to all of us. And now it's turn to get the theta. How much phase shift would be provided while the input signal get processed through that particular transfer function. So what it becomes, theta would be equals to of, see, because of a positive real value, there would not be any phase shift. I'm not going into the detailed analysis, but if it would have been minus sign, there would be a phase shift of a 180 degree. But okay, there has been one, and hence there would not be any phase shift because of its numerator. May I know how much phase shift would be provided by the 1 upon s? I know many of the students used to buy hard, sir, as it has been towards denominator side, and hence whatever the phase shift would be provided by the 1 plus s, that would be taken as minus over there. But you need not to buy hard that. You need not to buy hard that. Yes, why you need not to buy hard that? See, just try to understand why 1 upon 1 plus j omega. See, what you would be doing? You would be doing its rationalization. Once you'll do its rationalization, is gonna be 1 minus of j omega. 1 minus of j omega. Yes, put together is gonna be 1 minus of j omega divided by of 1 plus of omega square. So one thing had been quite sure, that you have come into the fourth quadrant. Why? Because the real part 1 divided by 1 plus of omega square had been a positive quantity, and similarly omega divided by 1 plus omega square had been a negative quantity. That means you have come into the fourth quadrant. And as you have come into the fourth quadrant, what does that mean of it? If you try to rotate anti-clockwise, the angle is being taken positive. If you take clockwise, the angle is being taken as negative. So that is why I know many of the students used to buy hard this concept. Sir, whenever the angle do come towards denominator side, we used to take that value as negative, but you need not to buy hard that, otherwise you would be in big trouble. If I'll give you one example, definitely you are going to be in big trouble. I'm saying you are going to be in big trouble. Agreed, no? What I'm saying? So what is going to be the angle over here? It's going to be simply tan inverse, just a minute, tan inverse perpendicular part. What's going to be the perpendicular part? The perpendicular part is going to be the imaginary part. That's going to be omega divided by 1 plus omega square. Yeah, omega divided by of 1 plus omega square. And towards denominator side, you would be having a 1 itself. And the minus sign do come over here. And the value at omega, where the theta has to be calculated, is being omega is equals to 1. So how much angle is being given? Is being minus of 45 degree. Minus of 45 degree. So I would say this has been your prime outcome. You have to focus on it. This has been your prime outcome. And now this complete system has to be converted or has to be replaced with its phasor form. And once we do so, the 1 upon 1 plus s in this operating frequency could have been replaced with 1 upon root 2, and it is going to provide the phase lag to the input signal and would be transferred towards output side, and it's been 1 upon root 2 with the phase lag of minus 45 degree. And obviously what happens, the magnitude just would get multiplied over here. So 10 gets multiplied with the 1 upon root 2, so it's going to be 10 of root 2, and here it becomes sine of. Keep in mind the operating frequency does not change how complex the transfer function could be. It could be s divided by 1 plus s, it could be s square divided by s cube, whatever the situation of the transfer function could be. Keep in mind the operating frequency which were present towards input side, it's not going to change towards the output side. The same operating frequency would be prevailed over here, but yes, there would be the phase shift, and the phase shift is gonna be lagging in nature, and more or less the answer which we are supposed to get is being 10 divided by root 2 sine of t minus of pi by 4. So whatever the answer have been given by most of the student had been the very perfect answer. So few of the critical point which has to be extracted from this particular problem. Keep in mind the response which we have got it's been a steady state response. If the student who are interested finding its complete response, they can do one thing. What they can do? They can take its Laplace transformation of the input. Obviously the transfer function has been the Laplace behavior of the system itself. They should multiply it. Now they had to take its Laplace inverse. Once they would take the Laplace inverse, even the component of e to the power of minus would also come. But that has been the component of e to the power of minus. As the time goes on, it would be keep decaying, and at steady state only and only pure sinusoidal signal would persist along with this problem. So one of the important most outcome, and that has been whenever this sort of problem do come, no, always they strictly ask the steady state response, because if they'll ask the complete response, no, this complete solution would become too bulky, because there you had to take its Laplace, then inverse, it becomes a too bulky situation to deal with. That's the first thing. Similarly, in the same sequence, I would like to write few of the more important point. The first important point, if you have an input, let's take the input is being a sine omega t phi. If you have a problem or if you have an input in this form, it's called a pure sinusoidal input. Why it's called a pure sinusoidal input? Because over the period of time, neither the magnitude nor the frequency of this particular signal is getting changed. That's the different thing. Even the phi is going to be 90 degree, this sinusoidal signal will become co-sinusoidal signal. So many of the time the student used to have one doubt, sir, if the input is being a co-sinusoidal signal, should I be referring it as a pure sinusoidal signal? Obviously, it has been a pure sinusoidal signal with a certain phase shift, with a certain phase shift. Could you understand what I am saying? Whenever it gets processed with any of the transfer function, what I would suggest to all of you, always convert the given transfer function into the form of phasor, where the R, which has been the gain which would be provided to this input signal at that operating system or operating frequency. Why I am saying operating frequency? Because as the value of omega is going to change, no, R is also going to change and theta is also going to change. So sometime in some of the books is also being written as a R as a function of omega and even theta as a function of omega. So always I would say replace S with j omega, feed the value of omega at to the appropriate operating frequency, and thereafter what happens, the output, may I know what would be the change over the output? The output is simply going to be R gets multiplied with the magnitude of the sinusoidal signal. It becomes R times of A. Sine would remain sine, and here theta, which has been the phase change towards the input, would get reflected towards the output side. So you can write in this way, omega t plus of theta plus of phi. So here changes takes place. The first change which has been taken place is been here. Yes, the magnitude gets multiplied with the R, the phase would get changed, and there would not be any change in operating frequency. So I would like to ask from each one of you, till this point, each and everything is clear or not? So for this particular problem, the most answer which we are going to have is going to be C. Few of the important critical points which we have extracted. This has been the steady state response. This is not the complete response, is the first thing. How do we solve this sort of problem? We convert the given S by j omega. We had to feed the omega from that critical frequency, and from there I would try to get its steady state response. Yeah, so everybody is saying clear, so probably it must be clear to all of us. In the same sequence, let me move forward. I know many of the students used to by heart, but I had to give a little bit idea of where they have been making the mistake. Let's take 1 upon 1 plus j. Yeah, tell me how much phase shift would be provided by this system. 1 upon 1 plus j, how much phase shift would be provided by this system? I know many of the students used to have a very bitter knowledge about the phase shift at least provided by the complex function. So let's take this has been the first question within the same question. How much phase shift would be provided by the system? 1 divided by 1 minus of j, how much phase shift would be provided by this system? And similarly third 1 upon minus 1 plus of j, how much phase shift would be provided by the third system? Because this sort of problem can be asked anytime over the Nyquist plot, and as we have been dealing with few of the complex functions, so why don't we take this problem here itself? Tell me how much phase shift would be provided by the first, second as well as third. I know most of us would be very happy to give the answer for the first, but definitely would have the problem in case of second as well as third. Only one answer have been received so far. Whoever is giving the answer, no, they should refer the question number first, and then only adjacent to that question number, they must be giving the answer over there. No, Amit, I would like to have the clear-cut idea. Minus 45 degrees being the phase shift for the system number 1, system number 2, or system number 3. Tell me. That clarity should also be there. Yeah, hers says the first would have the phase shift of a minus 45 degree. Tell me what would be the phase shift because of 2 as well as 3. I know you guys have by hearted this. Whatever the phase shift takes place towards the denominator side, we bring it towards upside and we just multiply with the minus sign. I know most of the student used to by heart that concept, and there is the problem where most of the student may get stuck if this sort of problem is being designed in future. As per the Mayur Patolia, for the 2, the angle which has been offered is been 45 degree. Anyways, we'll see that. Let's take the fourth also. Let's take the fourth also. It's been 1 upon minus 1 minus j minus j. Pranavi says the angle would be minus 45, 45, 135. Anyways, whenever you have this sort of problem, no, just use the basic concept of 11th, which we use in case of complex variables. My dear friends, it is not a standard form of the complex variable. Why? Because exact real part and imaginary part is not been known, which used to be in a form of a plus of jb. So obviously, to convert this particular complex function or the complex variable into the standard form, what we are going to do, we are going to use the concept of rationalization. May you know how the rationalization would be done? Always the rationalization would be done in such that the denominator should always be positive. Why? If the denominator also leads a negative value, because of that negative sign also there would be an introduction of the phase. So what we are going to do over here, 1 plus j is going to get multiplied with 1 minus j, and that 1 minus j would be as it is towards upside, and because of 1 plus j and 1 minus j there would be the multiplication, and obviously once the multiplication takes place, it's the simplest form of the identity which we use in case of mathematics. It's been a plus b, a minus b is simply going to be 1 square, that's a 1 plus of 1, that's simply going to be 2. So what's been the outcome over here? It's simply going to be 2 over here. And here it's been 1 minus of j, 1 minus of j. And if you would try to draw this over a coordinate system, let's take it's been a coordinate system. First of all, try to locate where this point would be exactly located. So obviously it's going to be at 4th quadrant. Why? Because the real part is been 1 upon half, and similarly the imaginary part is been a minus 1 upon half. So obviously it's going to be in 4th quadrant. That's the first thing. And next thing do come in the mind, whether the two had any impact over the angle. No, it does not have any impact over the angle. Why? We'll try to understand that also. See what's been happening over here. Let's take, you have reached to this point, yeah, this point had been half minus of j by 2, and you have been interested finding this angle taking the reference of positive x-axis, and you have been moving towards the clockwise direction. So obviously the measurement of the angle would be taken as minus. Now it would be, as you have been calculating this angle, it would be its perpendicular, this would be its base. So it's going to be 10 inverse of, may you know what would be the perpendicular? The perpendicular component is going to be the imaginary component. May you know what had been the worth of the imaginary component? Half. Many of the students, what they would do, here also they would write minus of half. You need not to do so. Why? Because of this minus sign itself, this point has been located in the 4th quadrant, and again if you'll be feeding minus sign over here, definitely you are doing the mistake. No, that has to be purely half. And now the base part is being half, and always you will see this factor gets cancels out because of the factor which had been present towards numerator and denominator. So what I would say, always forget about its denominator. Always just focus over its numerator, real as well as imaginary part divided by the real part, in which particular quadrant it has been placed in. Obviously you would be getting the angle out of it, and it's been a minus 45 degree. So yes, I can say the student who had been just by hearting from where the concept of angle is being come, so now this should have a clear-cut idea about it. In the same sequence, if I take the next one, it's going to be 1 divided by 1 minus of j. First of all, everybody should have a clear-cut idea what would be its partner while taking is rationalization. The partner has to be 1 plus j. I know many of the students would do mistake there also. Whenever the partner is being taken, no, the partner has to be taken in such, it has to be complex conjugate. What I am saying, it has to be complex conjugate. Why? Because once you will take its complex conjugate, no, always and always that factor, when it would get multiplied with this, you would be using the basic mathematical identity, the resultant would always be positive. I repeat, nobody should take this multiplication with a minus j minus 1. No, nobody should, means nobody should do that. Incomplete control system. Incomplete control system. So what is happening over here? The same thing is being happening. No, same thing. See, 1 minus j is going to get multiplied with the its complex conjugate, and once it happens, so it's gonna be 2 itself, again 2. And that's what I'm saying, whenever you have a factor positive towards denominator side, it is going to get knocked off. So in future, I am not going to worry about that denominator part itself. And once you have taken its conjugate, no, it's been a 1 plus j itself. It's been a 1 plus j itself. May I know where it's been placed? Obviously, it's been placed somewhere at first quadrant, and obviously again, it's perpendicular as well as base would have the length of 1 by 2 as well as 1 by 2, but I won't consider that 2 at all. 1 plus j, how much angle would be contributed by that? It's simply gonna be 45 degree, and here it's gonna be minus 45 degree. Such a huge change takes place. Such a huge change takes place. In the same sequence, if I take the third case, in third case, what's been happening, 1 divided by minus 1 plus j. Again, you have to take its complex conjugate, because any of the complex number is getting multiplied with a complex conjugate. What happens? Do you know that? Tell me, what happens? The resultant would be a pure real number, that's the first thing, and it's gonna be a pure positive value. It's a pure positive real number. Pure positive real number. Yes, if you have a complex number, that complex number got multiplied with its complex conjugate, the resultant would always be a pure positive real number, and that is what we want for. That is what we want for. Yes. So here what is happening over here? You will take its partner. Once the partner is being taken, again the resultant would be plus of 2. But now you have to be focused on what's gonna be its partner. The partner is simply gonna be minus 1 minus of j. In which quadrant it had been? Obviously it would be in third quadrant. And as it is been in third quadrant, this angle is also gonna be 45. Why? This is gonna be 1, this is gonna be 1. The student would say, sir, it's been half, no issue. But the 2 had been common at numerator and denominator, they are going to get knocked off. So this angle would be treated as positive. Why it would be treated as positive? Yes, it has to be treated as positive because we have been moving into the anti-clockwise direction till this 180 plus 45, and that has been 225 degree. And if somebody would say, sir, I would like to go from here and my angle has been minus 135 degree, then also fine, no issue. It has been the standard form to write both of the angles. Now let me take this one. 1 divided by minus 1 minus j. Again, the complex conjugate has to get multiplied over there. Again, the resultant would be plus 2 towards denominator side, but towards the numerator side, you had been left out with a minus 1 plus j. Yeah. So first you had to focus in which particular quadrant you had been placed yourself. So you have been placed yourself in second quadrant. Why? Because the real part has been negative and imaginary part has been positive. So somewhere here you had been. And if you wanted to calculate the angle, obviously you can take in anti-clockwise manner. Obviously you have to take the reference of positive x-axis always. Yes, no, my reference has to be fixed. Like if I take an example, the student might be studying from Maharashtra, might be studying from Himachal Pradesh. All of the different cities have got the different altitude, but those altitudes are calculated from a common ground. It's called mean sea level, which has been situated in Mumbai. So that's what I am saying. If I have been calculating the angle, I must take the reference of a exact line everywhere. I can't say like I have been teaching yourself from Korba, so I have taken the reference sea level maybe which has been kept in Karachi. If one student who had been watching my video had been sitting in Himachal Pradesh, he cannot take the different reference. The reference should always be taken from the exact point. As we have been taking the reference of mean sea level which has been situated in Mumbai, so always we take the reference from the x-axis itself, positive x-axis. So nobody should calculate the angle from here, because I have seen many of the students do the mistake over there. Plus of 135 degree. Plus of 135 degree. So may I know whether this concept was clear to you guys or not? Earlier I am saying. because I know many of the students used to just by heart. What they would do you know? Even you can relate by yourself. You'll calculate its angle, and as it has been kept towards denominator side, you'll just push it up and you'll multiply with the minus sign. You'll multiply with the minus sign, and there the question had the certain problem. The question had the certain problem. Tell me whether this concept was clear earlier or first time you could understand this. Anyways, keeping aside each and everything, you had to have a little bit idea about this all concept. You had to have the idea about this all concept. Yeah. Agreed? In the same sequence, see, probably few of the students would be there from the electrical stream also. What they do, whenever they deal with AC circuit, whenever they deal with the AC circuit, let's take here the inductance is being placed, here the resistance is being placed, and here the source is being placed. Let's take here, I had an inductor over here. Yeah. Inductor over here. It's been L, it's been R. And obviously the source what they used to have, if I take a standard reference, and that has been 230 volt RMS, 50 hertz single phase power supply. Now what they do you know that? They simply convert L into the form of j omega L. They keep R as R, and in future within the circuit, if there had been a capacitive component, they just replace that capacitive component with 1 upon j omega C. Why do they do same? Because they calculate the electrical parameter in steady state response. Because the L can also have its initial part, C can also have its initial part. At least AC analysis does not had that much visibility. So what I am saying, at least in AC analysis we do not focus more about its transient part and all. Otherwise in that case L cannot be taken as j omega L and C cannot be taken as 1 upon j omega C. From where this concept have come, that you tell me? C can be called of 1 upon Cs when the initial condition is being dropped, and now the S is being replaced with the j omega, and from there it had been j omega C. That means this complete concept had come from the basic that we have been focusing over its steady state response alone. Either it's this, either it's this. So in first semester or in power system, whenever the L being replaced with a j omega L, C is being replaced with a 1 upon j omega C, R remains R. Basically we have been dealing with its steady state response, either in terms of current, either in terms of voltages, whatever it might be. Yeah. Now I would like to have one input from each one of you. It's been a transfer function. Which kind of transfer function we have been taking? Deliberately I have been taking this sort of transfer function. 1 divided by 1 minus of S. Let's take it had been the first question. In the same sequence, let me take the next. 1 divided by S minus 1. Third, let me take third. And let's take it's been 1 plus S, 1 minus S. For the equation number 1, for the transfer function number 1, how much phase change or the phase shift we are getting with respect to the omega? Obviously 1 upon S minus 1, 1 plus S divided by 1 minus S. This system is big difficult. Tell me, again the same procedure has to be used. See, what we are going to do, we are just going to take its complex conjugate. You need not to replace S with the j omega. Unnecessarily you are spending your time to the very least crucial thing. Those sort of calculation has to be taken place in your mind itself. First, what we'll be doing, 1 divided by 1 minus of s, yes sir, it would be 1 divided by 1 minus of j omega. And what we are going to do over here, now we are going to take its complex conjugate. What's going to be this complex conjugate? 1 plus of j omega would get multiplied towards the numerator as well as denominator, and you need not to focus over its denominator, because the denominator is going to be pure real positive, and when you will take 10 no towards the perpendicular as well as towards the base, the same component comes towards denominator side. So it's simply gonna be 1 plus of j omega. May I know 1 plus of j omega would be in which quadrant? It's gonna be in first quadrant, so simply it's gonna be 10 inverse of omega. See, this is the way to solve the problem. This is the way to solve the problem. So far earlier we were discussing with the help of few complex numbers. Now we have been discussing with the help of few complex variable, obviously, and now this complex function has been the variable of omega. Yes, in polar plot, in Nyquist plot, in Bode plot, definitely you are going to deal with this. You are going to deal with this. Similarly, may I know how much angle would be provided by 1 upon s minus 1? How much angle would be provided by the 1 upon s minus 1? See, again the same concept has to be used. See what is happening over here. You can write this as minus 1 plus s. That would be the standard way, because taking its conjugate would become much easier. Towards the numerator side, it would be minus 1 minus of s. In which quadrant it's gonna be? It's gonna be in third quadrant. How much angle it's going to pursue? It's gonna be simply equals to of 180 into 10 inverse of omega. 10 inverse of omega. Because of 1 plus s and because of 1 minus s. Focus over the 1 plus s first. Focus over the 1 plus s first. May I know how much angle would be offered by it? How much angle would be offered by it? How much angle? Tell me. How much angle would be offered by it? Because of 1 plus s, the angle which would be offered is simply going to be 10 inverse of omega. 10 inverse of omega. Because it had been in first quadrant. Yes, everybody would agree on it. And now because of 1 upon 1 minus s, we have already seen what is happening over here. See, now you will take its complex conjugate. Once you take its complex conjugate, what it happens? Towards the numerator side, you had to add the multiplication of 1 plus of j omega. And because of 1 plus of j omega, how much phase shift do you have? It's simply gonna be 10 inverse of omega. So here it would be 2 times of 10 inverse omega. Anyways, this sort of problem do come into the picture when we deal with the all pass filter and all. And now one of the most critical conclusion we can retrieve out of it. If you have a complex function which had, let's take j1, j2, j3, j4. It's been a complex number. Which has been made because of the different complex number or the different complex variable. Let's take it's been a z1, z2, z3 and z4. I would like to ask from each one of you, mod of z, can it be written as mod of z1, mod of z2, mod of z3, mod of z4? Your answer must be yes or no. You should refer the question number 4 and your answer must be in a form of yes or no. Yes sir, whether it's a correct assumption or whether it's a wrong assumption. It's not even assumption. Yeah. Similarly, fifth, if you have been focusing over its angle, whether it's a true case or not, the angle which would be offered by the z1, by z2, and similarly z3, z4, whether both of the mathematical expressions are correct or not. Both I am saying. Not only fourth, even fifth also we have been asking. Tell me. because both of the properties would be used frequently when we would go in the detailed study of the control system. Fifth is wrong. Fifth is wrong. Anyone? Yes. What we used to buy hard, the cumulative phase which has been provided by the Z used to be angle because of Z1 plus of angle because of Z2 minus of angle because of Z3 because of minus because of angle of Z4, which is a wrong notation. So what you had to understand in this way, the angle which would be offered by the Z1 plus angle which has been offered by the Z2, and now rather taking the angle offered by the Z3 as a negative sign, you calculate the angle offered by 1 upon Z1 itself, Z3 itself, and similarly angle offered by the Z4 itself, and thereafter you have to just add them together. Just add them together. No, Harsh Kumar, that's what I am saying. Harsh, we had to learn a lot. No, Harsh, it's not always true. That's what I wanted to say over there. No. Otherwise, what I could have done in case of s minus 1, I could have calculated the angle which has been offered by the s minus 1, and definitely I could have multiplied with the minus sign. No. In BTech level, all of the sorcery based question which we used to see in BTech, no, in there most of the time it used to be valid, but it's not always valid. That is why I used to say, always remember this two important outcome. Always remember. Yes. Hers, could you understand what exactly I wanted to say? Because many of the times, if you'll see the towards denominator side, whatever the angle is being offered, if you multiply with the minus sign and you take its cumulative effect, many of the times you may go wrong. You may go wrong. Like you can take the reference of this only. You can take the reference of this only. No. So this has been the important conclusion which I wanted to conclude. This has been an important conclusion which I wanted to conclude. If you want, I can show you out what it has been. 1 plus s divided by 1 minus s. What I did, I took the angle which has been offered by 1 upon 1 plus of s, which has been tan inverse of omega, and similarly the angle which has been offered by 1 divided by 1 minus of s, which has been plus of tan inverse omega, had been 2 times of tan inverse omega. If you have any sort of doubt, I can solve this problem into the form of complex domain, and I can prove you that whatever I am saying, it's been perfectly well. It's been the perfectly well. See, 1 plus s could have been written as 1 plus of j omega, and here it's been 1 minus of j omega. 1 minus of j omega. Yes. How much angle we have been getting out of it? How much angle we have been getting out of it? That we have to calculate now. See, what we are going to do, we are going to take its complex conjugate of its denominator, and we have been multiplying towards numerator and denominator, and that concept is called once we do so, you need not to worry about its denominator, because whatever the factor do come, no, would not have any impact over the calculation of theta. But towards the numerator side, what it had been 1 plus of j omega. I repeat, 1 plus of j omega, 1 plus of j omega, and has been raised to the power of 2. Has been raised to the power of 2. एंगल इन डिनोमिनेटर बिकम्स नेगेटिव इफ नो यार निखिल, यही तो मैं बोल रहा हूं. नो, इट्स नॉट ऑलवेज, इट्स नॉट ऑलवेज. दैट इज व्हाई आई वांटेड टू मीन ओवर हियर. सो इट बिकम्स 1 plus of j omega square plus of 2 times of j omega. You will be calculating it and you will be getting the same answer. You would be getting the same answer. So that's what I am saying. So I would have a little bit idea that yes, in future, whenever I had a little bit problem based on the concept of the phase which has been provided by a certain complex function as well as the magnitude provided by the certain complex function, you must have a clear cut and thorough idea. Yeah. Chalo. In the same sequence, now it's time to take the next question. Here goes the next question. And I expect each one of us would be able to smash this problem out. Each one of us must be able to smash this problem out. What this problem states: consider the following system shown in the diagram. Now the system had been indicated by its transfer function, which has been clearly mentioned within the block is being s divided by 1 plus of s. In the system shown in the above diagram, xt is equals to of sine t. What will be the response y of t in a steady state? The four different options were allocated along with this problem is being sine within the bracket t minus of 45-degree lag divided by of root 2. What does that mean by the root 2? Root 2 had been the basic component of its magnitude, and you can say its amplitude of the signal is being 1 upon root 2. 1 upon root 2 with the lead of 45-degree, root 2, and now the output is being e to the power of minus t sine t, and it has become sine t minus of cos t. Sine t minus of cos t. Tell me what would be the best most answer which we would be getting for this particular problem. So unanimously we have been getting the answer as B, so probably B has to be the best most answer. Again, the same concept is being used, and keep in mind both of the questions has been experienced in past year gate examination. Probably the last question was experienced by the instrumentation people, and similarly this question was experienced by the electronics people. What the problem states: so consider the following system shown in diagram. Yes sir, it has been a transfer function of the given system. In the system shown in below diagram, input signal is being x of t, x of t is being sine of t, and now it is going to get excited with this input signal. I need to get its output. So what we had to do, we had to just focus over this factor s divided by of s plus 1. Operating frequency of the excitation input signal is being omega is equals to of 1 radian per second. 1 radian per second. So omega had been 1 radian per second. S has to get replaced with a j omega. J into omega, omega has been 1, and here it been 1 plus of j. 1 plus of j. Agreed what I am saying? Agreed? So it's the right time to calculate about its magnitude r as well as the phase which would be offered by this complex number. So R, may I know what would be the R? R is going to be the magnitude which would be offered by this particular complex number. I have seen already the important property which is being followed by the complex number. If you have been looking for its magnitude, you can take its magnitude of numerator separately, denominator separately. Not only that, if in numerator you have got the 3 or 4 different components, no, you can take the magnitude of the each and individual component separately. Still, you would not have any difference in its outcome. That's what I am saying. No, many of the times the student used to have just by-hearted one of the standard procedure. Sir, we will take its magnitude towards numerator, towards denominator, but you should also have a clear-cut idea whether logically it relates the same value or not. Yes, it relates the same value. Either you convert in a form of standard complex number, it's been a plus of jb. Either you take its magnitude towards numerator and denominator. In both of the cases, you are going to get the same value. So which one would be the easiest one? Obviously, taking the magnitude separately. The magnitude of j is simply going to be 1. And similarly, the magnitude of 1 plus j is going to be root over of 1 square plus of 1 square. It's simply going to be root 2. Yeah. Till this point, I don't find any of the student would have any sort of doubt now. Now, similarly, j, because of j, there would be the phase shift of 90 degree. Yes, sir. There would be the phase shift of 90 degree. Many of the students used to have one doubt, sir. Why? Because of j, there had been the phase shift of 90 degree. Just try to understand in this way. If you take a quadrant system plus j, what does that mean of it? That point is being kept over a positive y-axis. And if this point has been kept over the positive y-axis, if you will calculate the angle from the positive x-axis and that to in anti-clockwise direction, how much net worth of angle you had to follow? It's been a plus 90 degree. If instead the plus j, if it would have been a minus j, the angle would have been minus 90. If instead the plus j, if it would have been a 3j, still the angle would have been plus 90. Could you understand what I'm saying? And now because of 1 plus of j, what we are going to do, we are just going to take its conjugate towards the numerator side. It would become 1 minus of j, and put together it's gonna be in fourth quadrant. And in fourth quadrant, how much angle it's going to get? It's gonna be simply minus of 45 degree, minus of 45 degree. So obviously we had the angle because of j exclusively, and we had the angle because of 1 divided by 1 plus j exclusively. एनालॉग कंप्लीट कराइए, सॉरी EMFT कंप्लीट तो कराने का सोच रहा था, डेफिनेटली आई एम ट्राइंग हार्ड फॉर द EMFT ऑल्सो, बट मीनवाइल द रिकॉर्डिंग फॉर द कंट्रोल सिस्टम इज बीइंग स्टार्टेड. Otherwise, definitely EMFT probably we would go ahead with the concept through the question in Hindi, because in English already the EMFT is going to get taken place by the Karthik sir. It's been taken place parallelly. It's been taken place parallelly. Could you understand what I'm saying? So in natural, the value of R is going to be 1 upon root 2, and the angle which would be getting offered by this system is going to be 45 degree. So what is happening over here? The 1 is going to get multiplied with 1 upon root 2. It's going to be 1 upon root 2, and sine omega t is going to get leading angle of 45 degree. So may I know what would be the best most answer? Yes, all of us has given the correct most answer, and that has been B now. That has been B now. Yeah. So probably few of the important concepts which we have learned that should go in your copy. So now the 2 question has been taken in today's class, and in sequence 7 total number of questions has been taken. Now it's the time to take the question number 8, and now this problem is based on the concept of initial as well as final value theorem. Tell me what would be the best most answer. Probably the problem must be visible to all of us. If it is not, let me read this problem word by word. The final value of the function y of t, whose Laplace transformation capital Y within the bracket s is being 4 divided by s square plus of 2s plus of 2, is the 4 different kinds of the options were attached along with this problem is being 4, 2, 1 and 0. Tell me what would be the best most answer for this given problem. So probably you must be able to crack this problem out within maximum 60 seconds. Maximum 60 seconds. So the answer has started coming as per Sandeep Saha. The answer would be D. Anyone else? D. The another Silvaraj. Probably Silvaraj. Are you from Tamil Nadu? Probably yes. You must be from Tamil Nadu, because my boss was also from Tamil Nadu, Mr. Silvaraj. Anil Kumar says D. Yeah, just focus on this problem. This problem was based on the concept of final value theorem. Final value theorem. What does that the final value theorem says? Final value theorem is been an alternative method to calculate the value of a function in time domain in its steady state, or when the t has been tending towards infinity. So if you had a function or signal in time domain and you wanted to calculate its worth when t has been tending towards infinity, because precisely you can't reach to infinity. No, infinity is not been a reachable value. That is why I used to take t has been tending towards infinity. In Laplace domain can also be calculated with the help of final value theorem, and it's been limit s tends to 0, s times of the Laplace transformation of y of t. Laplace transformation of y of t. Yeah. and it's been the final value theorem. Many of the times the student used to have one doubt, sir. In case of final value theorem, why don't we have limit s tends to infinity? No, my dear friends, final value theorem is a theorem which calculates the worth of y of t when the t tends to infinity, or the worth of y of t at steady state. At steady state. Yeah. Anyways, I am not going into its derivation part, but otherwise in 5 to 6 different number of steps, we can even conclude how did I get limit s tends to 0 as the s y s is very same as the limit t tends to infinity as y of t, because it had got a pure relationship as well as the terms. Now tell me whether this particular theorem had got a certain limitation or it could be used everywhere. I would like to have the input from each one of you. Whether this theorem, which has been a final value theorem, had got a certain limitation or it could be used anywhere. It could be used anywhere. So if you say it could be used anywhere, you can just write everywhere. And similarly, if you have a certain understanding that, sir, it has got a certain limitation where it can be and where it can't be used, you can put it over the live chat. You can put it over the live chat. The first answer have come for a stable system only. May I know which limitation exactly we have? Which exact limitation we have? Yeah, see, final value theorem can be used only and only first. No pole at right hand side of S plane, including j omega axis. J omega axis. Yes, no pole at RHS of S plane including j omega axis, or more or less you can say, all of the poles has to be towards the left hand side only. Why I am saying pole? Because sometime those poles could be the roots of the denominator of the input signal, maybe the system itself, or maybe the multiplication of the input as well as system both. That is why rather referring it as a system, rather referring it as a signal, I have been just referring as a transfer function, and the poles of its transfer function is being referred as a poles. Keep in mind the poles should not go towards the right hand side, Yes. Why so? Do you have the exact idea about it? Why so? See, the final value theorem would be valid only and only for those functions which would be attaining its final value, final finite value, I can say. May I know which are the different functions would be attaining its finite final value? Either the function which must be converging a certain point, maybe towards 0, maybe towards 2, maybe towards 1, maybe towards -5, maybe towards a -5. Could you understand what I'm saying? See, the name itself is saying the final value theorem. Whenever the final value theorem has been applied, that function must be converging, reaching to a finite final value. So you can write somewhere, the final value theorem can be applied only and only on those functions which reaches to the finite final value or converges to a finite final value. Finite final value. Yes, finite final value, not even infinity, not even infinity. So may I know what is the basic requirement of it? The basic requirement is being all of the factors should have the factors like e to the power of minus t, minus 2t, minus 3t, minus 4t, and because of those factors always there would be a damping factor, and because of that damping factor always your response would try to converge to a fixed final value, and there the final value would be permissible, would be applicable. But instantly e to the power of minus t, if you have a e to the power of plus t, e to the power of plus 2t, in that case what is happening over here, because of that you would be having a exponent raising function, and once you have an exponent raising function, again it would be keep increasing and it would not be converging to a finite value. Could you understand what I am saying? So whenever the pole do come towards the right hand side, that means within that system e to the power of plus t, plus 2t, plus 3t is being present, and whenever all of the poles are being found towards left hand side, what does that mean of it? That means the damping factor e to the power of minus t, e to the power of minus 2t, e to the power of minus 3t is being present. Agreed what I'm saying? So that is what I'm saying. Like here the final value theorem is valid or not, that we had to see. It's been s square plus of 2s plus of 2. I would say you need not to search the exact locations of the pole. See, this has been the quadratic equation. The value of a has been known to be 1. The value of b has been known to be 2. The value of c has been known to be 2. Yeah. Once you calculate the roots of this quadratic equation, may I know what it used to be? B square minus of 4ac divided by 2a. I know many of the students would have calculated the distinct roots which we have got it, and from there they have applied the final value theorem, but you need not to do so. See how we can do that. You need not to calculate the square root of the b square minus of 4ac. You just calculate the discriminant. The discriminant is being b square minus of 4ac. Discriminant is being b square minus of 4ac. So what's going to be the b over here? The b is going to be b to the power of 2. That's going to be 4 over here. 4 minus of 4. What had been the a over here? It's a 1. And what had been the c over there? That's a 2. Put together, it's been a minus of 4. Minus of 4. My dear friend, whenever the discriminant is greater than 1 and less than 1. Whenever the discriminant is greater than 1, the roots are pure real. Pure real and distinct. Pure real and distinct. And here it's going to be pure real. It's not pure real. It's a complex conjugate. Complex conjugate in the form. See what is happening over here. Just try to understand this way. I have made ensure that the b square minus of 4 is going to be a minus of 4. That means the minus sign is going to get involved within the square root. That means this is going to just introduce a iota component. So forget about it. Focus over the b. If b is being positive, the minus sign gets multiplied over here. That means both of the root had the real part as negative, and as both of the roots had the real part as negative, what does that mean of it? That means both of the pole has been kept towards left hand side of the s-plane. Could you understand what I'm saying? I know, like in future it would become a s square plus of 3s plus of 3. No, many of the students would start thinking, sir, what would be the conclusion where both of the poles has been kept in? You need not to do those calculations at all. Focus over the b square minus of 4ac. If it's been negative, forget about this. Just focus over the b. If the b is being negative, b is being negative, that means the poles has been kept towards one right hand side also, and if b has been positive, by default both of the poles has been kept towards the left hand side. That's the first thing. Or even you could have taken the help of Rauthovitz also. Rauthovitz we are going to discuss in future. So see, the first row would be dedicated towards a polynomial of s square, and the last row would be dedicated towards the s naught. So here do come 1, here do come 2, and here it would be 2. And the last element which we are going to get over here is going to be 2 to the 4 minus of 1. That's going to be 3 divided by 2. And you can say, as there has not been any phase shift, that means none of the pole has been towards the right hand side of the s-plane. Again, the final value theorem can be applied. So I would say, whenever you have a complex polynomial towards the denominator side, you just search first whether either of the pole has gone towards right hand side or not, or j omega axis or not. If either of the pole have gone towards right hand side of the j omega axis, that problem is done, the final value theorem could not be applied. The two different methodology you can use. Either you can use the method of discriminant if you have been dealing with a second order system, or for any order system you can simply use the Routh-Hurwitz method, and at least you'll have a fair idea whether any of the pole is being there towards right hand side or not. सुरजीत रावल दास, आई विल शो यू, आई विल शो यू. आपको जो डाउट है ना सुजीत, आपको एक डाउट है, इफ यू वांट आई कैन शो यू. If you have that doubt, no, I can show you. I can show you by taking an example. You will be able to understand what exactly I wanted to communicate. The way you have been telling, no, that is not the correct one. That is not the correct one. Yes. Agreed, no? So Surjit Rabal Das, let me take an example. Let me take an example. 1 upon s minus 1, 1 upon s plus 1. Sujit, this problem goes for you. The Sujit says, sir, a myth for unstable system, final value not necessarily be infinite. It could be anything which cannot be predicted. Let me take an example itself. Let me take an example itself. 1 upon s minus 1, 1 upon s plus 1. Apply the final value theorem. Apply the final value theorem and try to get its answer. Try to get its answer. So if I apply the final value theorem, what used to be the final value theorem? 1 upon s minus 1, 1 upon s minus 1. What is happening over here? The s is going to get multiplied over here, and here it becomes limit s tends to 0. Limit s tends to 0. Here the worth which we are going to get, it's simply going to be 0. It's simply going to be 0. Yeah. And here if I apply limit s tends to 0, it's been s into 1 upon s plus 1, and here also we are getting the answer is 0. Answer is 0. Whereas if you'll do the analysis in time domain, 1 upon s plus 1 stands for e to the power of minus t into u of t. Obviously it would start from t is equals to 0, having the magnitude as 1, and at steady state it would try to dull down to 0. So obviously here it had been working fine. Here it had been working fine. But as far as 1 upon s minus 1 is being concerned, 1 upon s minus 1, if you'll take its Laplace inverse, may you know what would be the Laplace inverse? It's going to be e to the power of t u of t. E to the power of t u of t. Yeah, e to the power of t u of t. May you know how the e to the power of t u of t would be there? Obviously it would become continuously raising function. There is no doubt in future it is going to get settled at plus infinity hypothetically. That we know graphically. But how much answer we have got it with the help of final value theorem? That is nowhere near to infinity, and that has been 0. That has been 0. So Surjit Rabal Das, could you really understood what exactly I wanted to say? As you are saying, where the predictability is not there, I am predicting it. No, it's going towards infinity. So if I am able to predict according to you, the final value theorem would be able to predict its answer. No, it's no more going to able to predict that. It is just predicting the value as 0. But here the prediction as well as graphical outcome had been very same. Graphical outcome had been very same. So what I am saying, whenever the output reaches to infinity, keep aside each and everything. Whenever any of the pole goes towards right hand side, be mum of that. Surjit Rabal Das, could you really understood what exactly I wanted to communicate from here? Okay, let me do one thing. Let me give few number of homeworks. Just tell me whether the final value theorem can be applied or not. Can be applied or not. Let's take the first question. Let's take the first question. Let's take the first question is being 1 divided by of s square plus of 1. 1 divided by of s square plus of 1. Tell me whether the final value theorem can be applied for this particular Laplace form or not. That's the first thing. That's the first thing. Secondly, one upon s plus 1 has been raised to the power of 2 plus of 1. Obviously, you can expand x plus 1 to the power of 2 and you can get it where are the poles being located. Still, I would like to ask whether the final value theorem can be applied over this or not. Third, can be applied or not? Can be applied or not? In first, it can't. It can't. Why so? Because once you will take its Laplace inverse, no, you yourself would be able to understand. It stands for sine of omega. Omega is being 1 sine of t, which used to be a pure oscillating signal, and towards t tends to infinity, you would not be able to get its converging value where it has been converging. No, it's not been converging. It's been keep oscillating between -1 to +1. So obviously, you will not have its final value at all. You will not have its final value at all. Yeah, that's the first thing. So that is what I am saying. No, as the pole has been located over the j omega axis, the location of the poles has been at plus minus of j. So obviously, the final value theorem should not be applied over here. Although you can expand it, but from where this concept is being brought? See, this concept is being brought from e to the power of minus t into sine of t. You yourself would be able to understand how the e to the power of minus t sine t looks like. It is a pure damping oscillated signal. Obviously, it has been reaching to a converging steady state value. So if you will calculate now where their poles been located, obviously they would be located towards the left hand side, and here valid, not valid, and here it's a not valid because it's been a e to the power of t into sine of t. E to the power of t into sine of t. So okay, this is all for the today's class. What we are going to do in tomorrow's class, probably 5 to 6 difficult questions I am going to take from the concept of initial and final value theorem, and then we would move forward for the next concepts, and there I would be taking few number of questions based on the concept of transfer function and block diagram. Till then, bye bye, take care. Any sort of feedback you wanted to give, you can give it over the top chat. So definitely I would try to implement your those feedbacks also. I just wanted to make my classes to the interesting most as, yes. So for that, I need to have your inputs also. Any sort of improvement we can do over the lectures, which we have been dealing with the control system specifically, for me, you can put it over the live chat. Okay, then this is all for the today's class. Then we would meet exactly precisely at this time. Awesome classes, thanks dear. Still, see what happens if we had to teach many of the things through the concept question. No, it becomes a bit difficult, but still we will try to learn almost all important concepts through the question itself, because when you are learning the concept through the question, no, I have seen you guys are more interested. Okay, then this is all about the today's class. And Surjit, Rabidas, whatever the doubt you guys are having, no, you can ask the same doubt tomorrow. Definitely I would take that doubt tomorrow. Till then, bye bye, take care, good night, and yes, keep following the complete schedule which has been already shown over the digital board. The next class, when it's going to happen, the next class is going to be taken place at 6 p.m. PSA by Vishnu sir for the electrical, EMFT electrical electronics instrumentation 6 p.m. and similarly network analysis 9 p.m. Till then, bye bye, take care, good night.